Welcome to the lecture series on soft computing in computer science. So, in this lecture we are going to see how the MATLAB software has been used for developing any engineering based applications. It is not an application actually, but it is a problem statement in the particular area. So, this lecture is going to discuss about an application in network security, and the application is called as intrusion detection. So, intrusion you should know first what of all what it is, followed by why it has to be detected and what are the requirements for detecting intrusions, and it starts with data collection, and followed by data collection it starts with the MATLAB code development with respect to the data using MATLAB software. So, these are the overview of this presentation. What is intrusion? Intrusion is any intentional activity of a illegitimate user whose purpose is to gain access to the system without the knowledge of the owner of the computer. What is his purpose of doing this kind of illegal activity? His purpose is to exploit the software bugs and system misconfiguration, password cracking, sniffing unsecured traffic, and exploiting the design flow of specific protocol. So, these are all the activity that may be treated as a intrusion, and in a network security domain these kind of illegal activity has to be stopped or has to be prevented. How the neural network is helping enough to do this kind of detecting the intrusion? First of all, we need to have data about the model, that means the kind of intrusions carried out by the user. Once you have the data, so the various steps are already that we have explained in the previous presentation, like loading the data, separating the data into training and testing, defining the network structure, setting the initial values for weights and bias, training the network, testing the network, and display the result. See, the task of detecting intrusion is treated as a classification task whose objective is to accept the data from the domain, and it has to classify the data according to the category that are present in the data. So, here when you look at it, the complete flow of using the neural network for detecting the intrusion is, first you should look for the data. So, the data that is used is KDD CUP 99 data. So, it is a data that has been comes out from a data challenge competition in the year 1999. So, followed by data collection, the next firmest stop task is data pre-processing as well as representation in the form suitable for the ANN model development. So, as usual we need to conduct normalization of the data. Followed by that we have to select the suitable structure for the network, that is an architecture, that is input layer, output layer, hidden layer, how many nodes in the input layer, how many nodes in the hidden layer, and how many layers of in the hidden layer, as well as how many nodes in the output layer. So, those kind of steps you need to know. Then you have to perform training of the neural network model followed by testing of the. So, these two tasks are major tasks. After doing the training as well as the testing, finally it is the task to display the results according to the category available in it. So, the categories available are denial of service, probe, user to root, that is U2R, root to local, that is R2L, and in general it is normal data. So, this is the complete flow of development of an IDS intrusion detection system using back propagation neural network, or in general called as artificial neural network. data collection. So, this data is a little bit older data, but it is very widely used data with respect to the security domain, particularly IDS. This data is a simulated data and it is simulated by US Air Force local area network, and it has been operated like a real environment and being plastered with multiple attacks. So, there are enormous amount of attacks are available in this KDD CUP 99 data, and if you go through each data of these KDD CUP 99 challenge competition, each data comprises of 41 input features and one output label, and that label is designated as normal or any kind of attack. The attack may be of denial of service, probe, user to root, root to local. So, when you look into the data or when you observe the data consists of 41 input features with 5 class labels. So, very easily this kind of database detecting the intrusion task can be formulated as a classification problem, where the task is to read the data, develop a classifier model, and according to the classifier model we have to display the result in terms of accuracy with respect to the number of data that has been correctly classified. So, if you look at it, there are n number of input features, that is 41 number of input features are available, and the name of the all the features are given: duration, protocol type, service, and flag, source bytes, destination bytes. See, these are all the input variable name. Totally how many input variables are there? 41 input variables are there, and it is designated as F1, F2, F3, F4, F5. So, like that and all it has been designated like this: F9, F10, F11, like up to F41 input features are there. So, there are totally amount of MB size data. It may come around a disk or it may come around a huge capacity, but this application are not going to utilize all the data, but it is going to select some suitable amount of records from the data. So, totally how many number of samples have been taken from that MB sized data is 12,723 records, and these records have been distributed over the various classes like normal 5000, denial of service 3000, probe 3000, U2R 39, and R2L it is 1084. So, in this case, when you divide the data into training and testing, it is a normal holdout partition has been used, like 50% of the data is utilized for training and 50% of the data is utilized for the testing. So, the training data consists of 6363 and testing data consists of 6360, and the class wise distribution is shown here: 2500 for normal training as well as 2500 for testing, 1500 for DOS training and the testing. So, likewise. So, this is how the data is distributed in order to develop the ANN model. First of all, data pre-processing. If you look at the data, see, this data is not like data that we have discussed in our earlier presentation. It was about classification of the flour into 3 different categories: setosa, versicolor and virginica. So, like this it is not there. If you look at it, each feature, that is F1 to F41, you might see some numerical attributes and you may see some character attributes, right. If it is a numeric attributes, we do not have any botheration or we do not have any critical task in order to make the software to read the data and in order to feed the data into the model to do the calculations. But if it is a character data, it may contain some labels or it may contain some alphabets or it may contain some symbols. So, in such case we need to do some assignments for the data. Wherever name TCP is there, number 1 is assigned; wherever the number UDP is there, the number 2 is assigned; wherever HTTP is there, number 3 is assigned. Likewise, wherever you find some characters, some strings, for which you can assign some characters, some numbers, digital numbers, it may be a whole number or it may be a discrete number, but you should keep remember that the output is represented as a binary values, because how many output categories are there? There are 5 output categories. What are those? Normal, denial of service, probe, route to local, user to route. So, there are 5 output categories are there. All these 5 output categories has to be designated in the output layer such that the output layer will designate this output category. So, how many output nodes I need? 5 output nodes I need. See, here there is a confusion among the listeners. What confusion is? Each node is meant for each category. That is not the case. Each node will give, because the output of the neuron is always a binary values, it is a probabilistic value, but with the help of the threshold we may take either 0 or 1 from the output node. So, it may give either 1 or 0 according to the threshold that what we are setting, but it will give a probabilistic value to a particular category. So, if 1 is there in a particular node, then we may treat that node will be set for a particular class. So, if all the nodes are 0, we may say that the data is a normal category. If the node 1 has 1 present in it and all the other nodes are 0, then we may designate it as a denial of service. Likewise, a 1 in a particular position of a node, that means output node, we may categorize to a particular output category or a particular attack category. So, that is what we need to do during the pre-processing stage, very particularly in the representation stage. Data normalization, as I said in the earlier presentation, normalization is required whenever you are going to deal with enormous amount of variables and each variable values range is not within the smaller scale, but it may be a smaller scale, it may be a mid scale, or it may be a very large scale. So, when you are going to utilize all these kind of variables into the model development, there may be some chances that higher valued variable will begin to dominate or will begin to suppress or will not give any importance to the lower valued variable. So, in order to avoid such a situation, it is a best practice to go for normalization or scaling. So, the mathematical expression to conduct the scaling is there. Each variable has to be taken and its minimum value and maximum value has to be computed according to the starting and ending value of the variable. So, once you do this, all values has been changed into a predefined uniform ranges. Now, all the variables are in the same range, there is no higher valued variable, there is no lower variable, all are in uniform range. So, there will not be any bias towards a particular variable while developing the model during the training process. Selection of network structure, very important. So, how many input nodes? Number of input features is equal to number of input nodes. So, there are 41 input variables. So, 41 input nodes. How many output node? There are 5 category, but we may have 4 output nodes, because if all the nodes are 0, it comes to first category, that is normal. 1 in each node will corresponds to the other different categories. So, 4 node is sufficient, right. Number of hidden layer, only 1 hidden layer. Number of hidden nodes, so 10 hidden nodes. How to find the hidden nodes? It is a trial and error method. You can start with 2 or 3 and you can keep on increasing. How to decide the number of hidden layers? That also you can start with 1 or 2. So, in general, for a simple backpropagation neural network, 1 hidden layer is sufficient, which may have hidden nodes varies from 2 to 10 or 2 to 15, like that. So, in this case 10 hidden nodes have been used for a single hidden layer. So, what is the activation function used in the hidden layer? It is tangent hyperbolic function. And what is the activation function used in the output layer? It is linear activation function. So, this is the task of creating the neural network architecture to do the task of detecting the intrusions. Training process. So, the training process, there are 2 parameters you have to think about. So, one is epoch, how much iteratively you have to submit the whole input data. So here it is mentioned that 1500 times I am going to give the entire data to the model in order to understand the data patterns, because the objective of the neural network model is to study the underlying relationship between the input and output. So in order to doing so we need, for performing well to detect the intrusions, we set the epoch as 1500 times maximum we are setting the epoch. And what is the goal? Point not what the error level, that the acceptable error, that means the acceptable difference between the actual output as well as the network output is 0.001, that is almost both should be equal. So that is the aim. So what is the training error we obtained? So 9.997 into 10 to the power minus 4, so it means almost it has been crossed. What is the training time obtained? 257 seconds. So this is the performance training performance curve. So if you look at it, it starts from the value 10 to the power 1, slowly and gradually and neatly it has been reduced from 10 to the power 1 to 10 to the power 0, then 10 to the power minus 1, then it comes to 10 to the power minus 2, then slowly it reaches to the 10 to the power minus 3, around 1137 epoch, around 1137 epoch, right. So this is the performance during the network training. So testing, so normally one has to report the testing results. What is the testing results? It is the classification of the data according to the category wise for the trained network. So for the trained network, the testing error is 0.0097, of course it is a very good measure, and the testing time is 4 seconds. Testing performance, see we have considered 6360 data for testing the model. Out of that, the distributions of the classifications are shown here. If you look at it, out of the 2500 data that has been taken for normal, 2494 has been correctly classified. Out of the 1500 DOS, 1500 out of the probe, there has been some missing values. So if you calculate it, so it may come around 97.8%. Likewise for R2L and U2R. Overall, out of 6360 data that has been taken for testing, 6038 data has been correctly classified, showing the accuracy of 94.93%. So in this way you have to conclude the implementation of artificial neural network model for a specific application. So where to start? It starts from data collection. How? It has to be proceeded in such a way that number of input variables, number of output variables, and accordingly fixing the number of input nodes, output nodes, hidden layers, hidden nodes, initialize the network, train the network, then test the network, display the results. So that is the general procedures that one has to follow for developing the model. Now let me discuss the MATLAB implementation. So this is the code, and this code resembles the code that we have discussed earlier with respect to iris flower classification. I already said these 3 lines are my general practice to begin with my MATLAB programming, and these 2 line, you know that load training data. See here I have 2 different data files. One file is designated as TR data, that is training data, another file is treated as testing data, that is TE data. So I can go with any logic. Already said that, already I informed in the previous presentation that your entire MATLAB code development can be discussed in 3 phases. The first phase is the data loading, data separation, data preparation according to the ANN model development. The mid portion is nothing but network structure creation, initialization, training and testing. The last portion is visualization of the results, which needs some kind of logics in order to bring the network output to be mapped with the actual output. We need to do some preliminary work that will be based on some logics, right. So those, apart from that, everything are common. So it is very easy to rewrite the code that has been developed for the iris flower to any further data whose objective is to classify the given data into various predefined categories. So here the training data is there as well as testing data is there, 2 things are separately there. So training data is assigned to variable x1 y1, that is a TR data. As already said, x1 is meant for training input, y1. So I have to divide the data into x1, y2. So the last 41 input features they are there. So I have mentioned it as a list f equal to 41. So if I mention x1 y1, see, look at this command, x1 equal to x1 y1 all variables comma f, that means here f instead of f what is there, 41. So I need all rows, how many columns, 41 columns, 42, 43, 44, 45, the last 4 columns are meant for output. So I went for y1 equal to x1 y1 42, 45. So in order to carry out the testing data, so testing data is also did in the same way what the training data has been followed, same way in the same procedures, loading the data, assigning to the variable x2 y2, then that x2 and y2 has been separated, like x2 is having input and y2 is having output. Now we have x1 for training input, x2 for testing input, y1 for training output, y2 for training testing output. So now we have 4 variables. What the next step? Normalization. So normalization, since the y1 and y2 are already having the binary values 1 and 0, no need to go for that. Simply you assign the y1 to y1n variable. See, why these kind of variables and all, like y1, x1, and so we have to do variable like this only, we have to create. Is there any stringent procedure? No. In order to make it simplified, in order to make it clarity in understanding, I have used the variable like this. You can use any variable name for your purpose, right. So these portions are meant for normalization, of course the same idea that what we have discussed, and after normalization we are doing the network structure creation. So on network structure creation, number of hidden layer 10, number of output node 4 according to this, and the new ff method is there. So trained what is the activation function, the both the layers, how to initialize the weight parameters and the initialization of the net, then the epoch is set, goal is set. So train is performed using train and everything is made what is there in the previous process. So simulation is carried out using the sim command. So actual output is produced, network output is produced in small y, and it has been compared with the actual output in order to take the error. So after doing all these things, then we need to make a threshold. After doing the threshold value, we need to compare whether the s value and a value are equal. So in order that s and a values are changed to a single digit number like 0, 1, 2, 3, since it has a 5 category. In the flower category we have 1, 2, 3, but here we have 0, 1, 2 like that. Now both the s and a are verified. So out of the 600 360 data, how many data has been classified. So finally the graph has been plotted with maps between the input as well as the network output as well as the actual output. So let me execute this program. Since I have already tested the execution before recording this presentation, so I have listed out all the variables, otherwise it will be displaying as an empty workspace. So from the empty workspace we can get all these kind of variables. So the training process is going on. So maximum epoch is 1800, 1500. So the epoch is increasing one by one every time the training is carried out. So I think the epoch has been stopped around 1000. Yeah, here it is stopped around 1067, I guess. Yeah, yes, 1067 it has been stopped, and the time it has taken, the performance value, grading, so everything we got. So network diagram we can take by clicking this button. So it will show the network architecture. When you see the network architecture, you could find the how many 37 input. So there are some missing attributes, so it has been omitted as a redundant variable. So 10 nodes in the hidden layer, so 4 output variables, right. The performance curve, that is already discussed in the presentation mode. So performance, if you could see that the training curve, it starts from 10 to the power 0 here, and it is slowly and gradually decreasing, and finally it reaches the epoch at 1067. See the maximum classified class data. See if we could see the result. So what are the result we are getting? So first we are obtaining the mean square training error, then we are calculating the training time, then we are calculating the testing time, right, for which we are recording the CPU time at that time. So testing error, then the correctly classified data 6033. So from which you can calculate the percentage, that is 6000 CC divided by 6360, which is comes around 94.86. So, this is the accuracy of the model. So, this way you have to develop the model. So, if you could see that there is very easier stuff in it. The program that has been developed for doing the iris flower classification, same thing is enhanced, remodified and suitably adjusted with respect to this kind of application. So, one thing you should keep in mind, in order to apply this BPN model in a network security, particularly the problem of detecting intrusions, we need to collect data, and the data should be a supervised data. That means it should contain input variable and output variable. The output variable should have a class label. So, in that case you need to do all the steps of implementing the model, and you can develop the model in order to produce the classification results as illustrated just now. So, this is the way you have to develop the BPN model for any kind of application.